Hello and welcome to another set of examples for chapter 3, CSE259. In this example set, we will look at CTL parse trees and also some examples of well-formed formulas. Before we proceed, just a quick review of the operations. These are from the propositional logic. These are the same as LTL formulas. And these two are the new formulas that are added in CTL. A is along all paths and E is along at least one path. So diagrammatically, it would look like if you have these, then A would imply that all these have satisfy whatever comes in the formula, while E implies there is at least one, so there is at least one path, so it could be one or more of the paths. So this is CTL and the two new additions to make it CTL. When it comes to the operator precedence, when if you look at least to most binding, uh, the implication goes as the least binding. Then you have an or and the bijective functions from LTL, then the urinary functions. So you have a not, and then you have global and F, you have A and E, and finally you have the curly brackets. So this is the order of operational precedence. So now, having kept this, let's look at how the parse tree for this formula would come out to be. So there are lots of brackets, and let's match the brackets in the beginning. That forms 1, that forms 2, 3, and 4. So those are the brackets that we are looking at. The outermost brackets has an A and G outside and an implication. So writing out the formula, it will be A, G, and that has an implication. Implication has a P on one side, and the other side of the implication is this formula, which is an A followed by a U. One side of the U is a P, and the other side has this formula, which is got an and, which has got a conjunction or an and in the beginning. That's followed by a not P. On the other side of the and is got an A. A is followed by a U. The U has a not P and Q. So this forms the entire parse tree. Looking at the subformulas, so we start with the leaf nodes. So these two are there. Then we have a not P. Sorry about this. We have a not P. Then picking off from here, this is what is already known to most of you. So cutting it all short to the end and writing out the last bit of the formulas. Globally, P implies all paths have a P until there is no P, and all paths have no P until Q. So these are all the subformulas for the given parse tree. So practicing more of this will make it easy. It's very similar to what we learned in propositional logic, predicate logic, and the LTL. So this should be quite easy to do. Now, looking at well-formed formulas, what do we understand by a well-formed formula? Are these two well-formed formulas? So you look at the first one over here. A formula is well-formed if it follows the regulations of a well-formed formula. Otherwise, it is not. Looking at the two formulas over here, the first one, we have A all paths are not globally not P. Now, this is not a well formed formula because of not G. You, A has to be followed by either a G or a F or an X. It cannot have a not coming in between. So A not G is, and so it's not well formed. The other one, we have an A, E, and F. Are trying to read this in English. It's all paths. There exists a path in which future there is at least one R. Well, this doesn't make sense again. So if you look at the additional formulas that come into CTL, you have A and E. These are the two new additions into CTL. So A stands for along all paths and E stands for at least along at least one path. So A cannot go with an E as far as the formulas are. So either it can be an AF or an EF. AF ensures that EF is always true. So it is, if AF is true, EF is true, but we don't have an AEF. The idea is that we have to write this in proper English statements. So I would say A is along all paths, and E is there is a path. By rules of CTL, A can be followed by G, F, or X. Similarly, E can be followed by G, F, or X, while A cannot be followed by E. So, the above formula is not well formed. So, I hope this gives a view of how we write out whether it is a well formed formula or not. These are two examples of not well formed formulas. So, you can look at more such examples from the book, uh, either in the exercise, and some are given as examples in the book. Also look at the recording for section 3.5 to get more inputs into CTL. So that's it for this particular example set. See you in the next one. Thank you.